So today in college algebra, we're going to start our last unit. Okay, so we're going to be doing inverse trig functions, the first topic of this unit. And we're going to have to refer back to our unit circle. So if you have that available on the weekly agenda, please pop that up so you can refer back to it because it's going to be very important for what we're doing. Okay, so there are three inverse trig functions we're going to look at for cosine, sine, and tangent. Okay, now the important piece of this is each one of these inverses have restrictions on them. So let's go through them in order. First, we're going to look at inverse cosine. Okay, so for inverse cosine, what we're looking at is if you think about the graph of a cosine function, we want to get all the values before they start repeating. So this would be a cosine function, right? So starting here, and then by the time we get down to the bottom of our valley, if we keep going this way, we're going to start repeating the same values that we got over here. Okay, so with that in mind, if we started at 0 at the first point and went to pi for the second point, that's as far as we're going on the unit circle. Let's make that a different color so it's obvious. So we're going from 0 to pi before we start repeating our values. So we're going to only use the top half of the unit circle for our inverse cosine. Okay, so you can see up here our domain for theta is going to be 0 to pi. Okay, so that's the only place we're looking for these values. Okay, so how this looks is you have the inverse cosine. The inverse is signified by this little -1 of a coordinate. So this would be a part of the point, the x or y value of the point, that refers back to a specific radian between 0 and pi. Okay, seems a little confusing, but let's go through a couple examples and it will hopefully become not confusing. So we're doing the inverse cosine of 1 for number 1. So if you look at our unit circle on the top half of the unit circle between 0 and pi, we want to find an x value that's 1. Well, there's only one of them, and it is at 0. 0 pi, but 0 pi is just 0. Okay? Next, number 2. We're looking for a cosine value, so an x term on the unit circle on the top half of the unit circle between 0 and pi, where x is root 3 over 2. Well, again, there's only one. So x is root 3 over 2 at pi over 6. And then lastly, for number 3, looking for the x value where cosine is going to be -1/2, which is at 2 pi over 3. So basically what we're doing is trying to find on the unit circle where that point exists for that particular trig function and find the radian for where that point is. That's it. Okay, the tricky part is remembering the restrictions you have on the domain. Okay, now let's go to sine. So for the inverse sine, if you remember a sine function graph, I'm doing it in blue, sine function graph looks like this. Okay. The problem is, if we were to start here and go up, by the time we get to this point, when we start going down, we start repeating the values that we just had going up. So instead of going up and then back down, we can't have like a break in our values. So we'd want to start back here, but there can't be this break right here on our graph. So we're going to go backwards instead. So we're going to go from negative pi over 2 to positive pi over 2. So this is the values that we're looking at. All right, so we're going backwards on the graph to positive pi over 2, so which is why on our unit circle, we're looking at the right-hand side of our unit circle, from negative pi over 2 down here to positive pi over 2 up here. These are the values we're going to be using. Okay, now this becomes tricky because when we're looking at the values down here in this quadrant, we have to remember that they're going backwards on our unit circle. So although it might be, you might think that, we'd have 11 pi over 6 in that quadrant, it's really negative pi over 6 because we're going backwards. Okay, so you do the unit circle backwards on that part of the quadrant of the unit circle. So let's look at some examples. So we have sine of 1. So where is 1 on the unit circle on the y position? Okay, well, it's all at the top of the unit circle. It's at positive pi over 2. Okay. The inverse sine of negative root 3 over 2. So we're looking for a y value where it's negative root 3 over 2. It's in the bottom quadrant. So remember, we have to go backwards. Although it's at 5 pi over 3, we're not going to put 5 pi over 3 because we went backwards to get there. So it's going to be negative pi over 3 because we went backwards to get there. All right. Then we have the inverse sine of negative root 2 over 2. All right. So it's on the position of 7 pi over 4. But again, because it's in that quadrant on the bottom, we went backwards to get there. So it's going to be negative pi over 4. Okay, so that's the tricky part with inverse sines. All right, let's go to tangents. All right, a tangent graph looks like this. Okay, so again, if you think of a tangent graph, there is no repeating, but a tangent graph is divided in half by the y-axis. All right, so it is from negative pi over 2 to positive pi over 2. Okay, just like the graph is normally when you graph it on a coordinate plane. All right, one also quick thing to notice for this, if you looked at the domains for the other two for sine and cosine, you'll notice that they all have brackets around their domains. The brackets that are here and here, here and here, because you can include those values in your answers. But on a tangent, you have parentheses. This is because at positive pi over 2 and negative pi over 2, those are asymptotes. So they are not included in the values that you can come up with for tangent. Okay, so you can't actually have values at negative pi over 2 and positive pi over 2 for tangent because those would be asymptotes on a graph. Okay, just a little thing to notice. All right, tangent's a little more difficult just because a lot of times you have to deal with the fractions of sine over cosine. We're trying to give you some easy examples in this case because we're giving you negative 1, 0, and positive 1. Okay, so at negative 1, you've got to think where is the y, the sine over cosine, so the y over x, going to give you negative 1. Okay, well, those points are at the pi over 4 values. Okay, so either positive pi over 4 or negative pi over 4. Again, we're going negative pi over 4 because negative 1 would be at 7 pi over 4. But again, we went backwards like we did with sine. Since we went backwards, negative root 2 over 2 divided by positive root 2 over 2 gives you negative 1. So that means that value for the rating is negative pi over 4. All right, for number 8, tangent of 0. Okay, so we're looking for where the tangent value will be 0. There's only one spot for that. So you're going to have where the sine is 0 and the cosine is 1, which is going to be at 0 pi. We just don't put the pi down, we just put 0. Okay, so that's on 0. All right, number 9. Where is tangent going to be positive 1? Well, kind of like we did with negative 1. We're looking for two values that are the same, but this time they're both positive. So we have root 2 over 2 divided by positive root 2 over 2, which is going to give you positive pi over 4. Okay? So that's some pretty simple examples. Now we're going to get them a little more complicated. So when we're doing these inverse trig functions, you can go back and forth using the unit circle to find points and radians and then points and radians back and forth and have more complicated problems. They're not that complicated because you're still using the unit circle to do all this information. Okay, so let's look at number 1. We have the inverse cosine of root 3 over 2. So we're looking for the x value on the top half of the unit circle that is positive root 3 over 2. And you're going to find that at pi over 6. Okay, but then we have the sine of pi over 6. So again, what we're going to do is look at the pi over 6 values and find the y value, because that's what sine is, at pi over 6. And sine of pi over 6 is 1/2. So you're going to be able to go back and forth using the unit circle and the values that are on it to find the answer. Okay. So number 2, we have tangent of pi. So if we're looking at pi, what is the tangent? The tangent is 0 divided by negative 1, which gives you 0. So we want the cosine, the inverse cosine of 0. Okay, so where is cosine going to be 0 as a point? Okay, it's going to be at positive pi over 2 on the top half of the unit circle. Now, just a quick note, cosine is also 0 at 3 pi over 2, but that's not in the right domain because that's in the bottom half of the unit circle, and we looked at the top in our notes, where we're only looking at the top half of the unit circle because that's where our domain restrictions are. Number 3. Sine of pi over 2. So we're looking at pi over 2. What's the sine value at pi over 2? It's the y term, which is 1. We do the inverse cosine of 1. So where is cosine going to be 1? Where is the x term going to be 1 on our unit circle? All right, looking at the unit circle, that's where it's going to be 0 pi. So we just put 0. Number 4. We're doing the inverse sine of root 2 over 2. Now in this case, again, for the restrictions on sine, we're looking at the right-hand side of the unit circle. So where's the y value, positive root 2 over 2? That's at pi over 4. And the cosine of pi over 4, looking at pi over 4 again, what's the x value at pi over 4? It is root 2 over 2. Okay. All right. The inverse cosine of negative root 2 over 2. Again, we're looking at the top half of the unit circle. All right. So where is it? Negative root 2 over 2. The x value is negative root 2 over 2 at 3 pi over 4. And what is the tangent of 3 pi over 4? So the tangent is y divided by x. So root 2 over 2 divided by negative root 2 over 2 gives you negative 1. Now, just a quick note I was just thinking about for these problems. If it doesn't have a little negative 1 sign on it, there's no restrictions to where you're looking. You can look at the whole unit circle. It's only when there's that little inverse sign, the negative 1, on the trig function where you're restricted on where you're looking at. Okay. So we have cosine of pi for number 6. All right, so we're looking at pi. The cosine of pi is the x value at pi, which is going to be negative 1. We're going to find the inverse tangent at negative 1. So again, we're looking at the right side of the unit circle because that's the restricted domain. So where is tangent going to be negative 1? It's going to be where it is the two numbers that are going to be the same for x and y, but one of them is going to be negative, one's going to be positive, which is at 7 pi over 4. But again, remember, we're going backwards. It's going to be negative pi over 4. Got 2 more. Now we go more than 2 things. So first we start with tangent of pi. You're going to from the inside out. So you do the tangent of pi over 4 first. So at pi over 4 you have root 2 over 2 divided by root 2 over 2, which is 1. So we do the inverse sine of 1 and the cosine of that. So for this inverse sine of 1, we're looking for the y value there where it's at 1. And again, we're restricted to the right side of the unit circle. Okay, the sine value is at 1 at positive pi over 2. And we finish with cosine of pi over 2, so the x value at pi over 2 is 0. Finally, number 8. So we're starting out with sine of pi over 4. Sine of pi over 4 is the y value at pi over 4, which is root 2 over 2. So the inverse sine of that and the tangent of that answer. So the inverse sine of root 2 over 2, so we're looking at the right side of the unit circle, where the y value is root 2 over 2, which is, again, pi over 4. So we just went back and forth. And then finally, we're doing the tangent of pi over 4. So the tangent is the y divided by x. So root 2 over 2 divided by root 2 over 2, which is just 1. Okay? And that is it in inverse trig functions. Okay? As long as you can read the unit circle, you should be able to and identify which part of the unit circle you're looking at. For inverse cosine, it's the top. For sine and tangent is the right-hand side. All right? As long as you can read the unit circle, you should be fine with this. If you have any questions, please ask. And then please try the practice so we have something to talk about on Wednesday. All right, good luck.